Class Activity 12A looks at the units of length and area in the formula for rectangles. So, what does it mean to have an area? Well, by definition, that is when we cover a surface with 1 unit by 1 unit square tiles, and we can break those tiles apart and we can put them back together again, but we count how many of those tiles are on top of the shape. So what does it mean to say that a shape has 15 square centimeters? Well, that means that we have a shape like this square here that's 1 centimeter by 1 centimeter. So 1 centimeter long is 1 centimeter wide. And so this right here represents 1 square centimeter. So we could take and put 15 of these and fill in this rectangle with 15 of those square centimeters. That means that if we have a width of 3 and a length of 5, that we can cover this with 15 of these square centimeters. So we defined multiplication in chapter 4, so back in 1110, in terms of equal groups. So if we look at this large rectangle, the way we've drawn this, we can look at this as, if you remember the commutative property 2, here we have 3 groups of 5, so 3 groups of 5, or 5 groups of 3. When we look at the area of a rectangle, we can think of it as 3 groups of 5. So basically we have 3 rows with 5 of these 1 by 1 boxes in each one of the rows. Or we can think of it as 5 columns with 3 of these boxes in each one of these columns. Length times width works for rectangles, but does it work for other things? Well, not really, because what if we had a shape that looked as crazy as all that, and we wanted to find the area of this shape? Well, we could take and divide this up into 1 by 1 pieces, but as you can see, we'd have some that are whole and some that are not. So we would end up having to actually find out how many of these we could find and then put them back together again and just count them. So we can't always use length times width to explain area. So we have to actually talk about, again, going back to the meaning of area, where we can actually place 1 unit by 1 unit squares over the entire surface of whatever we're measuring and then cut it apart and bring it back together again. In number 5, we're given a line segment that's 1 unit long. This is 1 unit by 1 unit. So each one of these boxes represents a box that is 1/10 of a unit by 1/10 of a unit. So 1/100th of a square unit, because we're taking 1/10 times 1/10. It's asking us to lightly shade a rectangle that's 7/10 by 9/10. Okay, so we usually do length times width. So length is going to be 7/10 and width is going to be 9/10. Here's 7/10. 1, 2, 3, 4, 5, 6, 7. And then 9/10 would be to here. So we're going to want to shade in seven tenths of a row when there's 9/10 in each one of those rows. So here we have our 7/10 and here we have our 9/10. The area would be 7/10 of a group when there's 9/10 of an object in each group, so we'll end up with 63 hundredths. So that would mean we'd have 63 of these 1/100th square units. So these are our one-dimensional attributes. So 7/10 of a unit and 9/10 of a unit. And then our two-dimensional attributes are these individual blocks, which it's 1/10 by 1/10. So it makes sense if this is one entire unit, there's 100 of these squares in here, and each one of these is 1/100th of that square. So I wanted to draw your attention to the diagram in the book that goes along with this exercise. You can see here that, like most measurements, it doesn't always end up being a whole unit. So, like we did with the 7/10 and the 9/10, here we have 3.5 groups of 2.5 centimeters in each group. So that means we've got 1, 2, 3, and then a half of a group. And that's how we can find out the area. Each one of these blocks is 1 centimeter by 1 centimeter, or 1 square centimeter. So we've got 1, 2, 3, 4, 5, 6 of those square centimeters. And then we've got 1, 2, 3, 4, 5 halves of a square centimeter. And then we've got this right here, which is 1/2 of 1/2, or 1/4 of a square centimeter. So if we change these also, we can add them together. We've got 6 plus 10/4 plus 1/4 of a square centimeter. So 6 plus 11/4 square centimeter. So 11/4 would be 2 3/4 square centimeters. So we're going to end up with 8 3/4 square centimeters. And so it's entirely okay to just count out these blocks and parts of blocks, but we've also can use these as 3.5 groups of 2.5 centimeters. So I'm going to do that up here. This is a more advanced way of finding the area. So here's our 3.5 groups of 2.5 centimeters. So I'm going to change these to improper fractions. 3 times 2 plus 1 is 7 halves times 5 halves. So we're going to end up with 35/4, which is equal to 8 3/4 square centimeters. We've started out by looking at the meaning of multiplication, seeing this as 3.5 groups, and this is how we would draw that picture. And we can count them in a fundamental way and just add up all of the squares or parts of squares, or we can go straight to the multiplication to find the 8 3/4 square centimeters.